I would like to show you how I would attempt this homework problem. And in this homework problem, this is the sequence given, and its limit is 0. So we will need to determine the rates of convergence of this sequence approaching 0. Now, as I said in class, Taylor expansion is the key for this type of problem. So we need to expand cosine h. And then here's the Taylor expansion. The question is, how many terms do we need so that we can find the most accurate rate of convergence? So sometimes it takes a little bit trial and error, but of course we should keep something in mind. What we should keep in mind is this. So once we expand cosine h, after simplification, the terms in the numerator should be only one term, and you should be able to cancel h, and then you can bound the result. So that's the keep that in mind. So now let's decide how many terms we need to expand cosine h. For convenience purpose, I'm gonna write down some derivative of this function cosine h. To save the time, I write those derivatives here, and these are the values evaluated at the center x 0 equals 0. So now let's discuss how many terms we need for cosine h. So when we look at this numerator, we see 1 minus cosine h. So when we expand the cosine h, certainly the first term will be 1. The next term will be 0 plus 0 times x. And you can probably see that this 1 will absolutely cancel with this 1, right? So therefore, this 1 will be gone. And then we just need one more term because after simplification, the numerator will be just left with just one term. So that's what we need. So we're gonna say the next one, I'm gonna say it will be my error term. So I actually will not use this guy anymore. So I will actually stop here, f double prime at xi. So because f double prime is negative cosine, actually this should become negative cosine of xi divided by 2 factorial h squared, right? And now if you plug this into this expression, that's what we have. Cosine xi over 2 factorial, which is 2 h squared over h. Because of the limit is 0, we really don't need to write a minus 0. This is a little redundant now. So this is equal to, if you look at that, it's cosine xi over 2h squared over h. And h squared and h cancel, you're left with h. And now that's where we can bound. So make sure that you should have a xi after simplification so that you can bound, because cosine is always less than or equal to 0, less than or equal to 1. So I can safely say it's 1 over 2 times h. That's what we left with. And now you can say this is big O of h, right? So this is how we should attempt this problem. I would like to demonstrate why we should only use that many terms. You should not continue. And you can quickly see that if you don't stop here, if you continue, and this is what you will have, like h squared, the next term will be 0. Suppose the next term is, which is this guy now, is your error term. So you're going to plus cosine of xi over 4 factorial h to the power 4. If you plug in this Taylor expansion into your original expression, you have 1 minus this whole thing, right? This whole thing plus cosine xi over 4 factorial h to the 4th divided by h. Do you see that after dropping the parentheses, and actually this 1 and 1 will cancel and this will change the sign, and you have 2 terms in your numerator, and if you simplify, this is what you have: minus 4 factorial cosine xi h to the power 4, power 3. So now how can you bound? You have 2 terms and it's not a good way to bound, right? So, and that's why we are gonna say the trick is expand enough terms so that when you simplify, you have only 1 term here to cancel out the denominator. So that's it for this particular problem.